12 from 1-6. And a lot of some of the questions in 1-6A, we used a substitution method to solving. Like, do I want you to change that into a radical and get rid of it? No. What you want to do is substitute in, okay, then change it so it's factorable, and then work your way backwards. So if I am doing that method, I always want to look at this second term. If it is squared and it gets you the first term, then you know you can do this method. So because something raised to the 1/3 squared would be something raised to the 2/3, I can use this substitution method. So I take whatever is being raised to this 1/3, this whole thing, I'm going to make A. It could be any variable you want, but they tend to choose A mostly, so we're going to follow suit. So I'm going to make that A, and then I'm going to replace that term with A, and this first one would be that term squared. So this is going to be A squared plus 2A minus 3 equals 0. Yeah.
So how does 2 over 3 equal squared?
So 2x minus 1 to the 1/3. If I square it, when you square, you multiply out the exponents, right? So 1/3 times 2 is 2/3.
Oh, okay.
Right? So that's why we can do what we're doing. Because that would be squared. Yep. All right, so I'm going to rewrite it as this. So A squared plus 2A minus 3. And then we can factor it. So I'm looking for the factors of -3, Factors of -3 that sum to 2, which would be +3 and -1. I'm going to split and solve this, set them each equal to 0, and A equals -3 and A equals 1. But we're not solving for A, we're solving for X. So now I got to come back to what I substituted out for A and put it back in. So -3 would equal 2x minus 1 to the 1/3, and 1 would equal 2x minus 1 to the 1/3. And then I want to get rid of the 1/3. So how do I eliminate an exponent that's a 1/3? Raise it to the second power. Or raise it to the third power, sorry. So we'll do it on both sides. So the 1/3 raised to the third power cancels it out. -3 to the third would be -27 equals 2x minus 1. And then add the 1. -26 equals 2x. Divide by 2. And x is -13. That's one of my answers. Go to the one on the right. I raise them both to the third power. 1 to the third power is still 1. These cancel. I get 2x minus 1. And then add the 1. And then divide by 2. And there's my other solution. So I get that x equals -13 and +1. All right, so the check to see if you can use that substitution method is by looking at the first term and the middle term, okay? And you could look at it two ways. Is if I take that first term, whatever's got the exponent, if I square root that, do I get the middle term, ignoring the coefficient? Or the other way around, if I take that middle term, which would be ignoring the coefficient, which means this, 2x minus 1 to the 1/3, if I square that, do I get this first term, okay? So if I take 2x minus 1 to the 1/3 and I then square it, what happens to my exponents when I raise an exponent to an exponent? I'm going to multiply them. So that makes this exponent become 2/3. And because that is what that first one is, I can use the method of substitution. So that just tells you that you can do it. But then the actual method is to replace whatever we squared. So we're going to replace this 2x minus 1 to the 1/3 with another variable, and usually it's a, but it doesn't have to be a. So then this first term is going to be a squared plus 2a minus 3 equals 0. And now it is something that we are familiar with, right? We can now factor that. That's easy to factor. I'm looking for the factors of the last term that sum to the middle term. So this would be A, and the factors of -3 that sum to +2 would be +3 and -1. And then I split and solve that. Split and set them both equal to 0. And I'd get A equals -3 and A equals 1. With me so far? Okay, but I'm not done, right? That's what A equals. But I substituted in for A, so I really then have to take that and say 2x minus 1 to the 1/3 equals -3, and 2x minus 1 to the 1/3 equals 1. And then I'm going to get rid of the 1/3 by raising both sides to the third power. These cancel out, and I get 2x minus 1 equals -27. I'm going to add the 1. 2x equals -26. Divide by 2, and x equals -13. Yep.
Okay, I'm lost on the part.
And now I have to repeat that process to the right-hand side. So I'm going to raise this to the third power. The 1/3 to the third cancels that out. I would just get 1 as my exponent. So I get 2x minus 1 equals 1. Add the 1. 2x equals 2. Divide by 2. And x equals 1. And I get x equals -13 and +1. All right, so this one, again, when you look, like if I look at the middle term and then I square it, do I get that first term? So if I take the square root of x and I square it, do I get x? Yes, right? So I get to do that process again. This time I would say that a equals the square root of x. So then I replace it, God bless you. This would be 6a squared minus 7a minus 3 equals 0. Then I'm going to factor. So you can either do trial and error or first times last. If I do first times last, I get 6 times -3, which is -18. Are there factors of -18 that sum to -7? Good. -9, +2. Replace the middle term with them. And then factor by grouping. So from the first set of parentheses, I could take out a 3a. Second set of parentheses already matches that. So my greatest common factor is 2a minus 3. And then I group together what's left, 3a plus 1. Then I split and solve it, set it equal to 0 and equal to 0. 2a equals 3, divide by 2, and a equals 3/2. 3a equals -1, divide by 3, and a equals -1/3. Am I done? No, because that's the a part, right? So now I have to plug it back in with what a equals. So square root of x equals 3/2, and square root of x equals -1/3. So on the left, I square both sides to get rid of the square root, and I get x equals 3 squared, which is 9, 2 squared, which is 4. But on the right, I have a problem because it says the square root of something equals a negative number. Is it possible to get a square root that equals a negative number? So we literally just rule out that part as though it's like an extraneous root. And your only answer is 9/4. So if your original question has that square root in it, which we're going to do a little bit more in that next, like section 1.6b, those square roots rules kind of come back. But we've done them before where if that original question has a square root, you have to make sure it doesn't equal any negative numbers. Yeah.
Why can't 94 be simplified into 3 over 2?
Because you're square rooting it, not dividing by the same number.
Oh, so you can't simplify?
Nope. The same number has to be a factor of both. Like you have to divide it into it. Yeah.
So why did you put,
Because no square root can equal a negative number.
how did you get 1/3?
I solved this over here.
Oh, okay.
Yeah. So that came from 3a plus 1. So if you go, I pulled up 4 first because I got a lot of questions on 6 and 9, but I'm also going to go over 4 because 4 is the foundation for those two. So this was 4 from the homework, and it says x to the third plus 512 equals 0, okay? So if I'm going to actually solve this question, you cannot just move the 512 to the other side and cube root it, okay? You actually have to factor this out. You do use SOAP. Yep. So this is a perfect square. These are both perfect cubes. X to the third and 512 are both perfect cubes. So we have to factor this as though it's a perfect cube. So I would cube root the x to the third, I get x. I would cube root the 512, and that's 8.
I have a question.
Yeah.
Are we going to have big numbers in?
They wouldn't be that big. No.
They're going to be like more
Like a 64 or 125, something you're used to. Yeah.
I have a different number.
Okay,
Is it normal?
same process.
Okay.
Yeah, the red means that everybody gets a different number there. All right, so then I would factor that out. So remember, it's those two terms, then the square of the first one, then the product of the two, then the square of the last one. And then my signs, same, opposite, always positive. Now, when we were factoring, we're done, but we're not factoring anymore. We're solving. So I'm going to set that equal to 0, and I'm going to set this equal to 0. The one on the left, easy to solve. That's my -8, so I get that one real answer. And now x squared minus 8x plus 64 is not factorable. You'll never be able to factor the right side of your SOAP. Like, it won't factor. So I have a quadratic there that you actually could either use quadratic formula or complete the square. And because that middle term is even, I don't think it's that awful to do complete the square on this one, okay? But you could also do quadratic. How many of you would choose quadratic formula? Raise your hand if you would choose quadratic. How many of you would choose complete the square? All right, well, let's review. So we'll do both, okay? So the first one to do is quadratic. A would be 1. B is -8. C is 64. And I get negative b, so it'd be 8 plus and minus the square root of b squared minus 4 times a times c all over 2 times a. And I get 8 plus and minus the square root of 64. 4 times 64 is 256 over 2. And then 256 minus 64. This should be 192. 8 plus or minus negative 192 underneath the radical. The I is going to come to the outside. And then break it down. So it'd be 2 and 96, 3 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2.
4 and then 3 inside.
2, 2, and the 3 is left underneath. So I get 8 plus and minus 8i root 3 over 2, and then 2 goes into both those. Plus the 8 you got from the real part of your factored form. So that would be if you did quadratic, okay? You don't have to do both ways, but I'm gonna do complete the square too because obviously it's good to review this stuff. So from here, if I wanted to complete the square, x squared minus 8 plus 64 equals 0. I'm gonna bump the 64 over. Take the 8, divide it by 2, that's 4. 4 squared is 16, add the 16, add the 16. Factor the left side, so it's x minus 4 squared equals, and that would be negative 48. Square root both sides. X minus 4 equals plus and minus. Square root of negative 48. First the I comes out. And then this would be 2 and 24, 2 and 12, 2 and 6, 2 and 3, or bring out a 2, bring out a 2, 4I root 3. And then just add the 4 at the end. This time, complete the square is definitely easier. But again, you don't forget that negative 8 that you have from the beginning.
How did you get the 16 and treat it as square?
Take the 4, divide it, the 8, sorry, divide it by 2 and square it.
Oh, okay.
So once you move the 64 to the other side, you got to find what C is. Yeah.
Did we go over number 6?
Not yet. That's next. Yeah. So questions on that process, because that is then going to get, this now shows up in 6 and 9. Okay. This is, I don't know what your numbers are, but this was one of the 6s. No, I think they were all the same. Yeah. So this is it said x to the 4th minus x to the 3rd plus x equals 1. So if I move the 4 to the other side, I get x to the 4th minus x to the 3rd plus x minus 1 equals 0. And there are 4 terms. So what do you do when there's 4 terms? Factor by grouping. From the first set, you could take out an x to the 3rd, and you get x minus 1. And then the second one is already x minus 1. So there's really a 1 there, which means I have x minus 1 and then x to the 3rd plus 1. So the x minus 1 part I can solve, but now the x to the 3rd plus 1 is a perfect cube again. So we're back to SOAP. So when I factor that, the square root or the cube root of x to the 3rd would be x, cube root of 1 would be 1. And I'd get x, 1, x squared, 1x, and 1. Same, opposite, always positive. So when I set the first parentheses equal to 0, I get x equals negative 1. So now I've got one answer, 2 real answers. And then I have to take that x squared minus x plus 1 and solve it either using the quadratic or complete the square. So because these are smaller numbers and that middle term is not even, I would probably have done quadratic this time. A is 1, B.
To do so, you just take them and then for the second
You cube root it to get the initial. And then it's those 2 for the first parentheses, the square of the first, the product of the 2, the square of the second. And then the same opposite, always positive. So I get negative b, which would be b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. 1 plus and minus the square root of 1 minus 4 over 2. And then you got to take out the I. So 1 plus and minus I root 3 over 2. So there are 4 answers, okay? The 1, the negative 1, 1 minus I root 3 over 2, and 1 plus I root 3 over 2.
you get 4.
From where? The equation is 4AC.
No, the answer said it was like the answer made you type it in differently.
You took out the 1/2, right? Yeah. Which I think I said last week, like sometimes it's going to make you do that. I don't need you to do that for your quiz, okay? Sometimes it puts it, like it will literally just take out that 1/2 and make it all, it doesn't matter.
Is this the one we just did?
No, we just did 6. So 9 has an x to the 6th and an x to the 3rd. So this is where I would use my A substitution, okay? Or you could factor it, but the first term is going to be x to the 3rd instead of x to the 2nd. So you could either factor it this way. Now find the factors of negative 8 that sum to 7. Or I could say x to the 3rd equals a, and I could use the substitution method at the beginning. So let's say I'm doing it that first way, and I have x to the 3rd and x to the 3rd. What are the factors of negative 8 that sum to positive 7? Positive 8, negative 1. Now I'm going to split and solve these, but I'm going to factor both of them because those are both perfect cubes. So do it from there. All of you do it from there. Like take those, factor them because they're both perfect cubes. and then get to the answers using either quadratic or complete the square. Yeah. The highest exponent there actually tells you how many answers you should have. So because it says 6 here, there should be 6 answers. That's 6 answers that could be real. They could have eyes on them. You could get one that repeats. So like if you get, maybe you get -1 twice, that counts as 2 answers. Okay. But the amount of answers you have, if you're talking real and unreal, if you're talking real, it may not happen. Okay, like the eyes, if you count the eyes, then you should have just as many answers as you have at the highest exponent. All right, so on the left, if I'm going to factor that out, right, the cube root of x to the third would be x. The cube root of 8 would be 2. So I'd get x and 2. I'd get x squared, 2x, and 4. Same, opposite, always positive. Then I'm going to set that equal to 0 and this one equal to 0. I get x equals -2. That's the real part of it. And then for the second one, did you raise your hand if you tried complete the square? Okay, raise your hand if you did quadratic. Okay, so I don't think they're that bad this time either because it's even again. But let's do quadratic because that was what most of you said. So -b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. 2 plus and minus the square root of 4 minus 16 over 2. 2 plus and minus the square root of -12 over 2. 2 plus and minus, the I comes out. 12 is 4 and 3. Square root of 4 is 2. So this would be 2I root 3 over 2. And then they're all divisible by 2. So 1 plus and minus I root 3 plus the -2 that came from the front. We good so far? Yeah? Yeah.
So the one in the radical doesn't also have to be divisible by 2?
Correct. Yeah, you can actually. You can't touch something outside the radical with something inside like that.
And if it was, you still wouldn't, you'd just leave it the same?
Correct. All right, then on the right-hand side, you've got your other perfect cube. Okay, so we would factor this, x, 1, x squared, x, and 1, same, opposite, always positive. Split it, set it equal to 0. So I get x equals 1. That's another real answer. And then I get x squared plus x plus 1, which I wouldn't do complete the square if you had the choice. So I would do -b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. -1 plus and minus the square root of 1 minus 4. -1 plus and minus the square root of -3. -1 plus and minus I root 3 over 2. So I've got these 3 answers. I've got x equals 1, and I've got -1 plus and minus I root 3 over 2. So 6 answers there. 6. 1, 2, 3, 4, 5, 6, because those are plus and minus. Yep.
But we don't have to write it like that.
You do not. Nope. WebAssign wants them separated out, but as far as like an open-ended question on a quiz or a test, you could totally leave it as plus or minus.
How many of these are going to be
On what?
on our quiz?
On the quiz, there's no x to the 6th.
They expect the fourth.
Could there be a cube? Yes, but there's no x to the 6th. Could there be an x to the 4th? Sure. Yep.
So whatever it is in the front, how many answers?
So that
Correct.
would be like 4 answers, right?
Correct. Which we did those, right?
Yeah.
That was- So 13, right? Because t to the 2/3 is the same thing as t to the 1/3 squared. I would say a equals t to the 1/3. And then I'd get 49a squared plus 28a equals -4. And then you move the 4. So 49a squared plus 28a plus 4 equals 0.
Yeah, I got that one. That was it.
Okay. What's true about both 49 and 4?
They're divisible by 4?
No.
I had the same question and I got -8 and it said it was right.
I was trying to figure out when we did
That's
perfect.
it can't be
square
the same.
triangle.
No, you have different numbers, Sam.
Same, bro.
You have different numbers. Wait, but what's true about both 49 and 4? What do they?
Square.
They're both perfect squares. So test to see if this is a perfect square trinomial, right? So square root it and it's 7. Square root it and it's 2. Does the middle term equal twice their product? Yes. So this is a perfect square trinomial. So it'd be 7a and 2. Put a plus between it. Square it. Equals 0.
Man, that was way easier than what the guy said to do on Watch It.
Yeah. Let me finish it. Let me finish this first. But then we're going to solve for a, right? So I would square root both sides. I would do plus and minus, but it's a 0, so it doesn't matter. 7a plus 2 equals 0. 7a equals negative 2. A equals negative 2/7. Now, there are 2 of them because of the plus and minus, though, which is why it matches that it would be squared. So, like when I said before, remember that if it's the same answer twice, you don't need to list it twice, but realize that it's important that it's there twice because that's why there's 2 answers.
So that's plus or minus 2.
No, it would be 2 because it would be a plus and minus 0, but it's still just negative 2/3. But that's what t to the 1/3 equals. So now you got to set it equal there. So you got to cube. You would cube both sides. 11, same process. The thing in the middle, it's ugly, but the thing in the middle, when I square it, I get the first one. So because this is the square root of this, or the other way around, I square the middle term and I get that, I use substitution. So a would be x over x plus 2. And then I'd get 2a squared minus 3a minus 2 equals 0. And then you can either do trial and error, first and last. I would do first and last. 2 times negative 2 equals negative 4. Product of negative 4, that sum to negative 3 is negative 4 and positive 1. 2a squared minus 4a plus a minus 2. And then factor by grouping.
I like the factor by grouping. Those are right. I can do that.
I can do that. Those are good.
I think you like lost me in the factor by grouping, and that was it.
On this one? Oh, okay. So then I go from here. All right, so then I'd split and solve a equals 2, 2a equals negative 1, and a equals negative 1/2. But that's your a.
Oh, I know that school.
I got negative 2/3.
I don't know that school. I do know that school. They got free shirts. Hold on, there's schools.
Hush. So that's your a. So I would say 2 equals x over x plus 2, and negative 1/2 equals x over x plus 2. The one on the right I would cross multiply, and the one on the left just multiply by the x plus 2, get rid of it out of the bottom.
It's not the same. Like, it's weird.
I took a picture of hers, so hers is the same.
Question.
Yeah.
Would it be the same thing for the like 2 equals x over x plus 2 if we just put it over 1 and like cross
Yeah.
multiply, that's the same
Yeah.
thing?
Mm-hmm.
That makes my brain confused.
What is
So then subtract the 2x. 4 equals negative x. X would equal negative 4. And on the right, you can cross multiply.
Oh, wow.
Negative 1 times x plus 2.
It's not like, is it too late to go back to like algebra 1?
Yes.
It's like asking if it's too late to go back to pre-K for halftime.
They're not that far behind.
And then I get 2a squared plus 5a equals 3. 2a squared plus 5a minus 3 equals 0.
It's different.
Okay, but the numbers are different, right? What?
Number 13.